Good morning. Thank you so much for joining us today for Confidence Starts Before the Upgrade. Know your ZOS environment before you move forward. Before we get started, I'm going to be going over just a couple of notes. We are recording today's session. It will be available to you after the session is over. I'll be emailing everybody with the ability to get a link to this session as well as the slides if you'd like to share it with someone else or go over some of the points again on your own. Also, we'll have Q&A open. Go ahead and type your questions in as they come throughout the presentation. We will be saving time at the end of the presentation to answer any of the questions you may have. That being said, let's go ahead and get started. As you know, today we're talking about staying modern, and one of the big issues with not making sure that you're up to date with your operating system, it's not only just about the risks it impose, but also complication of compliance and just the delays with the critical security enhancements. Now, while you're getting there, it's not about just getting to that release, but it's about doing it with confidence and trust. And that's kind of what our entire presentation is about today. So with that being said, I'd love to hand it off to you, Paul.
Okay, thank you, Sammy, for that introduction. And as I welcome all of you, I'm sure you would agree with Sammy that her opening statement rings true, that today it's not just about getting to the next release, it's doing it with confidence because that confidence leads to improvements in productivity and efficiency and overall gives us a better understanding of the value of our own work. So this is a critically important task, particularly now as we approach the sunset of 3.5 sometime late in September. Now, our approach to this is to employ a form of AI, and when I say that, what I'm talking about are rule-based applications that are based on the image focus platform. So a lot of what I'm going to show you, if you're an image focus user, you may have some familiarity with, but it will look quite different from the classic view that you have of image focus and how it presents its results. Now, an important point, I think, for me to make here is that these rule-based applications, these rule-based AIs, are different from the way people normally think of AIs today. This is sometimes referred to as old-fashioned AI, whereas things like LLMs and advanced world models and artificial superintelligence are based on probabilistic methods that result in findings, but those findings represent probabilities, and those probabilities can be incorrect. We all know about hallucinations, et cetera, et cetera. The kind of results that are produced by rule-based applications are deterministic. That is, that once a prediction is made, it's relatively easy to audit it. It's relatively easy to trace it back to its origin. It's relatively easy to understand how the model actually made such a prediction. Such tracing is simply not possible in an LLM or any other form of large language model. The other aspect of this, which is critically important, is that rule-based applications need to have access to their environment. They need to be able to retrieve information from them. And so quite often they're referred to as rule-based retrievers. It would be impractical to develop a model to analyze ZOS and just simply have those rules sitting in an application if that model didn't at the same time have the ability to be able to extract the specific ZOS application, which is the target of the model's activity. So one of the advantages that we have with image focus is that for years we've been developing those extractors, being able to develop the tools that are necessary in order to be able to give us a better understanding of the environment that we are operating in. And when I say that, I don't just mean the operating system. I mean JES, VTAM, TCP/IP, all of the security components, many of them in the area of security, excuse me, network security, and being able to aggregate that information in a way that allows it to be easily accessed by the applications that are using the rule base in order to present that information to you directly. Now, you might ask yourself the question, why was this necessary? Why did we decide to take this particular path? And the reason for most of you that use image focus should be relatively clear. Image focus is what you might think of as a big data generator. A typical single ZOS environment, including JES and VTAM and all the other stuff, might generate a trace, a log of its activity, the detail of its activity, that auditability, if you would, that could include somewhere up to 30,000 records. Doing exploratory data analysis of such a large data set becomes cumbersome. And because of the size, many of the features that image focus is capable of producing in its log are sometimes or often overlooked. So it's typical for people to look, oh, do I have a risk? Is there an error or a warning or a notice? Or maybe I should try to search for that. But they overlook things like the data set report and the volume report, the dynamic change report, and all the other reports and other information that is included within that large data set. All of the work that is done by image focus is based on if-then conditional logic. And all the work that is done by the supplemental applications that we call AIs are also done on if-then conditional execution. So if in fact what is necessary in order to be able to demonstrate the accuracy of a prediction, then we are able to do it. And we're able to work with our clients, our customers, in order to make sure that they understand and that we understand what is necessary in order to produce an accurate prediction. Our work is based on IBM documentation, user documentation, our own experiences, and other sources of information that we use to train the model. We don't use the techniques that are used by LLMs, which is essentially to have them, in many cases, self-trained on information that might come from the internet or perhaps from internally in your organization, the value of which, the quality of which, the veracity of which is often called into question. So with that said, let me tell you where we are today. We've currently been able to develop 5 such agents. These little AI agents are intended to help you specifically to perform a better job of doing your daily task, which we see as backing up, leveling up, firing up, and linking up ZOS images in order to be able to move forward as quickly as possible to the next version of the operating system or subsystem. So let's have a closer look at that, and we'll get a better understanding of exactly where we're at. So today, as I mentioned, we have 5 such agents. They're represented here by these little agent icons, if you would. The first of which is TCE AI. That's the control editor AI. The control editor, much like image focus, generates tons of information that is stored in a highly secured vSAN cluster that gives it the ability to be able to extract and classify what the excuse me, what the storage entities are by using techniques that allow it to group them together in categories. And these categories can often lead to a better understanding of all of the information that might be included inside that vSAN cluster. again, it's a method of trying to distill the information and augment the search for findings that might appear in either the database or in image focus. Another one is certificate intelligence AI. Certificate intelligence AI has a very close relationship with RACF, the RACD cert, ICSF, and other components that are necessary in order to manage certificates properly. Like others of these AIs, it presents its initial findings in the form of a dashboard. In this particular case, it presents it as a summary of all of the certificate entries in the RACF data store and indicates those that are weak, need to be examined in more detail because of the size of their keys. This is particularly important in light of AI and quantum computing, which is on the horizon. Valboot AI is a helper that can assist you in establishing the clean room that is necessary in order for you to move forward with secure boot. It does things like builds key rings and certificates that conform to the requirements of the clean room and providing you with a clear path to move that information forward to the HMC for an attempted IPL as a secure boot. And of course, IPL Check AI, perhaps the best known of all of our AIs at this point in time, works autonomously with the IBM Health Checker for ZOS to continuously monitor the IPL path of a given system image. Not only the IPL path, but also any dynamic changes that may be occurring to that system that should be noted or taken into consideration before the next attempt at an IPL. Its scope is quite large. It can do up to 32 images at a single time, and so it is quite a robust little tool. But today we want to talk about zTuneUp AI. It's our upgrade readiness specialist. It's going to help us to be able to understand and move on to the next release of ZOS. So how does it do that? Well, essentially, what it's going to do is throughout the process of performing an upgrade to the next release, it's going to track your improvements and what we refer to as drift. And you may have heard the term drift used in many different circumstances in ZOS. It essentially means that you have some sort of a reference point. And as you move forward in time, the particular element that you are tracking is changing. And what you want to know is how it has drifted from that base point. And so we're going to not only track the improvements that you're going to make, but we're also going to track the drift that might occur in dynamic changes and configuration parameters. To start with, we're going to perform a risk evaluation. And that evaluation is going to allow us to compare two separate inspections, one for the base system at its current release level to determine if there are any risks that exist in it currently that should be cleaned up before you attempt to move that configuration to a new release of ZOS, and then a target system that's being evaluated at the target release level. So in our case, this would be a move from 2.5 to 3.2. In this process, what we're going to be able to do is track the improvements that are being made and determine the risks that exist between the two existing systems. Now, it's possible that there may be risks that we identify in the base system that are not, let's say, modifiable by you. There may be security parameters and other things. So there's opportunities to fine tune this process by excluding the various findings that seem irrelevant to you at the time at which you're doing this analysis. The drift analysis for dynamic changes and for configuration parameters are done in real time, and they reflect changes that may be specifically a result of your activity or a result of team activity. In either case, the results that you'll see are specific to you. Each individual that uses zTuneUp AI has his own instance of the agent and can use it independently from any other user of any other agent. So there's a lot of value here for you to use it in order to strengthen your resilience, reduce the risk, and restore trust. Now, to sum it up, what zTuneUp AI is going to do is establish a trusted ZOS baseline. That's a critically important part of moving to the next release. It's going to discover IPL path risks and changes. It's going to identify configuration release updates that need to be made. It's going to validate update readiness for possible drift. And it's going to highlight opportunities for improvement. Things like removing obsolete params or reporting on subsystem releases that are available that are beyond the current release that it's in your current configuration, like CICS, for example. It's typical today that all of the components of the ZOS, IPL, PAT, JES, VJM, TCP/IP, etc., are all at the same release level. But CICS stands out as being unique. And so pointing out, for example, that CICS has a new version is critically important to understanding the work that may need to be done beyond just simply the operating system and the IPL path. Of course, through all this, what we're attempting to do is reduce the risk of migration to any other future release of ZOS. That is, once you get used to using this, it should become relatively easy to begin the process, a cycle, if you would, of moving to the next release. This is not a tool that should be used once. This is a tool that can be used over and over again once the release cycle is completed. The outcome from all of this is that you get to move faster and upgrade with confidence. Now, much like the other AI agents that we make available that depend on the image focus platform, zTuneUp AI presents its results in the form of a dashboard. So when you log on to it for the very first time, it's going to take a snapshot of the configuration as it exists on the system that you're logged on to. And it's going to present that finding in the form of a panel. And you see that here, and we'll go over it in detail here in just a moment as we get in to the demonstration. But remember that the first thing that we want to be able to do is make sure that we understand fully the configuration that we're using as our base, and that we understand any inherent risks that are currently embedded in it, and do what we can to try to straighten that out before we move to a new release of the operating system. The next thing I want to point out is that once a finding is available, it's presented in another form of dashboard, which you can see here. You can see the stack again, OPSIS, JES, what we call Z-AIDS, we'll explain that in just a minute, VTAM, CICS, etc., etc. Clicking on any one of those will turn the row that it's in white, and will then present that information in more detail down below, showing the concerns that exist in the source and the concerns that exist in the target. And then, of course, clicking on any of these will let you drill down specifically into the problem as it is referred to in the inspection log for either source or target. It's here where you get access to dynamic changes and also where you get access to the zTuneUp baseline. There are opportunities to copy, view, print the reports and other output that come from this process, and also to email it dynamically to those that you might be working with. And that email could be standard email, or it could be uh, communication server SMTP or CS SMTP. Either one of those is possible. So what I'm going to do now is I'm going to stop sharing this, and I'm going to move over, and I'm going to, if I can here, just a moment. And I'm going to get Zoom out of the way. There we go. Okay. So this is the panel we were looking at earlier in the slide presentation. This is the uh, dashboard, if you would, that you'll see when you enter the system for the first time. Again, we see the stack here, OPSIS, JES, whatever, whatever. We see the source and the target up at the top. The source is always the system that we're logged on to, in this case, SOW1. We identify its VM user ID, ZOS25M, and then we determine if we have a hardware name, we could put that in there. We determine the release level, which is provided automatically, 2.5. We repeat that information down below, although we could target another system, not necessarily SAL1, but we could do another system as long as it was locally available. And we target a new release level, in this case, 3.2. So when we run this process, when we kick off the finding, what, excuse me, what we're going to do is pass all these params to image focus, and we're going to ask it to perform an inspection for us that we can use as the basis for determining whether or not, one, there are any risk in the current configuration, and two, as we move on to the target, to compare those two to make sure that we understand what the differences are between the source and the target. Now, I'll just show you what that might look like. I'm not going to do it because it's going to take a while. If you're familiar with image focus, you know that a normal image inspection might take somewhere between 2 to 3 minutes. But what you'll see is this panel. And what it's asking you to do is to specify whether or not you want to continue. And you can see the params that are being passed through, the VM name, the release level, whether JES is turned on, VCAM, TCP/IP, CICS. And for CICS, we need to specify a suffix for a command member that contains the start commands that are used to start the specific release of CICS that we have available to us. Now I'm going to just hit PF3 and back out. So now we're back to our original panel. Let's take a look at some of the detail that we have here. First of all, if we look at the operating system, if we just put the cursor under OPSIS and press enter, we'll see a panel that shows us all of the errors, warnings, and notices that appear in the OPSIS inspection. And if we're curious about this one, we just simply put the cursor under it and press enter. And now we can see in this inspection log, which is probably about 22,000 lines long, that we've been positioned at the first instance of that particular message. So IFO 0769I and what that means, and here's all 5 of them lined up. So instead of having to essentially use some unique, personal method for exploratory data analysis. This gives you direct access to the information that you need to be able to understand what's going on. If I back up, we'll see right below that an item that's called exclude, EXC. And you see a line next to it that allows you to enter various image focus messages in order to exclude them from the analytic part of this, not from image focus, but from the analysis itself. We may look at IFO 0496E and say, well, that's stuff that applies to validated boot, and I'm not interested in that in here. So I would just like to remove all of those. So I can go take a look at exclude, and we can see here that that particular message, it's the second error in the report, and there are 3 of them, that all of these are related to secure boot. Now, there is one other that is related to secure boot, IFO 499E, that also has a problem, but we decided not to eliminate that specifically for this demonstration. So a lot of information is provided that gives you an opportunity not only to look at the specific risks that are being presented through the inspection process, but also to take action in order to exclude those that are not of interest. They would both be excluded from the source and the target. We can move on to JES, to the aids. The aids as we define them are the health checker, ICSF, ZOSMF, ZFS, and HMS. And typically, these aids are started as part of the IPL process. And if the process for starting them were to fail, they would be reported as failures or as errors. You can see now, because they are in green, they are just simply informational messages. VTAM, CICS, as I mentioned, we have to provide that command suffix, IF in this case. And then moving on to TCP/IP, which includes the resolver, profile, telnet, TCP data, and OMP route. And then IPsec, which includes CERT-AUT, a critical RACF profile that protects the majority of your ports and IP processes that needs to be understood and put in place and inspected, and Image Focus does that job. And its companion Pageant, which also does a similar job for HETLS and IPsec and other components such as policy-based routing. Now, once all that's done, the finding is going to show up here, as we showed you earlier. And to mimic what I showed you in the slide, I'll put the cursor under CICS. And now we see the CICS configuration risks as we currently see them. Now you can see some of those risks are associated with findings from Image Focus directly. And some of them are findings from CICS directly. You can see that in this particular case, the source and the target have exactly the same risk. So there's no difference between them from moving from one release to the next. And you can see that summarized up here at the top. 2 errors, 7 warnings, and 1 notice in the source, 2, 7, 1, and nothing is being excluded. So this is a full inspection of CICS from the perspective of Image Focus. There are no changes in the 10 risks that were associated with CICS, and there were no excludes. And so there is, if you would consider it, full disclosure of everything that has gone on in comparison from one of these to another. Putting the cursor under any of them and pressing enter. Oops. Well, I didn't expect that. See if we can do better. Well, sorry about that. Let's try something like ops is. So you can see here, this is similar to what I showed you on the first page. This is telling us that we have warnings of a specific kind. In this case, protection is inadequate. And if I PF3 down, you can see that this extends quite a bit. Again, doing this visually without an aid of this kind could become quite cumbersome. So this should give you some appreciation for not only the size of the log itself, but the complexity of the findings that are presented in it. And it's relatively easy to get lost in here, and it's relatively easy to overlook something. So you don't want that to happen, obviously. And so one of the primary purposes of zTuneUp AI is to assist you in the exploring of the data that's in the log itself. You can see they're spread out quite all over the place. I'll back up. Well, you can see as we go forward, this one got lit up. It turned white. Only things that are shown in white are actually selectable at this point in time. Any number of things, TCP/IP, couple of warnings. I'm not sure what's going on here. Always a little embarrassing to do these things live. Nope. All right. Let's try this one. Huh. Well, I'm embarrassed. Excuse that, please. All right. Well, that notwithstanding, I think you get the idea. We do the inspection. We present the stack, OPSIS, JES, AIDS, UTAM, CICS, TCP/IP, IPsec. We present the risk findings, errors, warnings, and notices and excludes for both the source and the target. Then we compare those two to determine if there are any specific changes. You'll notice here that as it relates to JES, we had 65 warnings in the source, and now we have 65 errors in the target as we move to 3.2. So here we have a situation where the number of changes, adds and deletes from the source to the target in terms of risk are now presenting themselves and probably should take on some. Here are those errors. So this is in 3.2. And here we have a similar picture shown as warnings in 2.5. You'll also notice that this guy's showing us obsolete keywords as well. So another method that can be used to help with improvements. All right, so that's the upper part of the panel. The inspection's complete. We have a source result, a target result, changes and excludes if we want to exclude anything. And then we have dynamic changes below. And in dynamic changes, we can see the SIM list, APF list, BPX, PRMX, LPA, and the linked list. And if there are differences that exist between them, then we can look to see what those differences are. So in this case, there are 7 items that were deleted from dynamic changes, in this case for LPA, and we can see what those particular items were. Some were actually deleted from the current profile of the LPA list. Some were previously there, some were previously not. As the case may be, they're currently all gone. We can view the baseline. We can look at the LPA excludes. There aren't any currently. And then we can look at the zTuneUp baseline. In this case, we're looking at deletes, and we can see all the members that have been deleted. So this allows you to drill down directly into the log and pull out whatever information currently exists for that. And this just goes on and on. So we can update the baseline. And then, of course, when we're done, we can go back out, and then we can make some changes if we choose to do it, and then we can run the process again and see what the results are. As I mentioned earlier, this is a personal environment. This is one where the changes and other things that you see here are specific to you, so that you can do your work the way you choose to do it without regard for any other teammates that might have their own version. If you're interested in the classic view that's provided by image focus, you can do that for both the source and the target. And of course, drill down accordingly. So if this is another method, if you would, that you might be familiar with, which is available to you as well. Okay, so let me shut this down. I'll come back and we'll wrap this up. All right. So if by now you might be scratching your head and saying, yeah, I know, but I haven't gotten to this yet. Don't feel particularly bad. Lots of people haven't gotten to this yet. That is upgrading to the next version of ZOS. In this particular instance, 3.1 or 3.2. The statistics that you see here are based on IBM numbers at the end of March of 2026, which indicated at that time that 10% of the community, at least as included in their survey, was currently out of service. That is, they were running a version of ZOS that was no longer supported. 30% we're running 2.5. And of course, 2.5 is going to go out of service in September. So assume nobody changed anything, nobody took the action to begin to move to a new version. We might have up to 40% of the community which is out of service sometime in September. Half, roughly, have moved to 3.1, and 10% have moved to 3.2. So if you're feeling sort of under the gun here, you're not alone. There are a lot of players out there that have work to do to move their ZOS systems to new releases of the operating system. On the average, the community is about 27 months behind the current release, that is 3.1. So time to get busy. So what we propose is an AI agent that can work alongside you, as you see here in this picture, which can combine your human expertise with its AI insights. And we believe that the operational confidence and trust in your work will improve, and that you will feel more ready on the day that you begin to perform that migration to the next release. I want to thank all of you for your time today. And before I turn this over to Sammy, I want to point out that this is a relatively inexpensive process. The agents cost $2,000 per LPAR per year. And if you need more of them than that, then you can talk to us about our enterprise pricing. I think you'll find that equally economical. Thank you again. Sammy, back to you.
Wonderful. Thank you so much, Paul. And thank you again for everyone who joined us today. If you're interested in trying this out, we do have 60-day evaluations available. Or if you want information on how we can help you on your specific environment, we're happy to get on a one-on-one call. As I mentioned earlier in the presentation, I'll be sending out an email to everybody who came today with um, a the availability to get a link to this recording or the slides. You are welcome to reply to me with any feedback you have, including if you'd like to set up a call with us directly. We would love to speak with you. Thank you again and have a wonderful day.
Bye-bye, everybody. Bye-bye.